This video today is designed to help you understand and be able to solve and graph linear inequalities when they are in standard form. Standard form is when the x and y variables are on the same side, and you have to solve to get y by itself into y equals mx plus b form, or slope-intercept form, so you can identify the slope and the y-intercept in order to graph. Now remember the rules with inequalities. If it is a greater than inequality, you will have a dashed line and you will shade above that line. If it is greater than or equal to, it will be a solid line and you will shade above that line. If it is less than, it is a dashed line and it is shaded below. And if it's less than or equal to, it is a solid line and you shade below that line. Now, let's go on to our first example of 3x plus y is less than or equal to negative 5. Now I'm going to rewrite my problem to the right-hand side. There's not enough room to show all of my steps underneath the original problem, and because of the coordinate plane that's given to us. So we're going to solve this way. So we have 3x plus y is less than or equal to negative 5. We know that our goal was to get it into y equals mx plus b form, so we can identify the slope and the y-intercept. In this case, we want to, or in every case, we want to solve for y. So in the process of solving for y, you will always, in your first step, eliminate the x and its coefficient from the left side. In this case, we have 3x. So when you completely eliminate a variable, you will do this by adding or subtracting. So your first step, you will always add or subtract whatever the value of x is. In this case, it is a positive 3x, which means we are going to subtract 3x from both sides. And when I mean sides, I use the inequality as a divider. So when we subtract negative 3x from both sides, it eliminates the negative 3x on the left-hand side. That will bring down our positive y, which will bring down our inequality. And then what we have, that's all that's left on the right-hand side of the inequality, is we have a negative 5 and a negative 3x. I like to put them in y equals mx plus b form, so you know that the variable and its coefficient, the variable x and its coefficient will come first, and the term that's just a numeral will come second. So we have a negative 5 and a negative 3x, so we'll rewrite it as negative 3x minus 5. From here, which that is our solution, but we need to graph this solution, so we need to identify our slope, and we need to identify our y-intercept. Our slope is negative 3, so we will write that as negative 3 over 1. Our y-intercept is negative 5. And remember, the y-intercept is always on the y-axis, so I'll put my first point at that negative 5. Now my slope tells me that it's negative 3 over 1, which would be down 3, right 1. But if you would look at our coordinate plane, we cannot go down and right. So what you can do is you can always take that negative and move it to the bottom numeral, or the denominator, or the run. So now it's 3 over negative 1, which means that you will go up 3 and left 1. So if you can't go down and right, go the opposite of both, up and left. So I'm going to go up 3, 1, 2, 3, left 1, and you can now see my new point, or my second point that I have. And with this, I know that I am going to be graphing my line, and since it is less than or equal to, this is going to be a solid line. And I am going to shade below, so I'll pick any point on my coordinate plane, go below it, and you can see the shaded area below for our solution. Another example would be 10x plus 3y is greater than negative 15. So I'm going to rewrite that. 10x plus 3y is greater than negative 15. I know that I'm going to be solving for y. So I'm going to separate my sides. And the first step is always to add or subtract the x values. In this case, it's a positive 10x. So I'm going to subtract 10x from both sides. Now I cannot take 10x away from negative 15 because they are unlike terms. Remember, you cannot add or subtract unlike terms. So I'll bring down my 3y, bring down my greater than inequality, bring down my negative 10x, because you want your x value to come first, and bring down my negative 15. So now I have 3y is greater than negative 10x minus 15, but still we have to get y by itself. So I will separate my sides again, and on the final step, you will always divide by what is touching, or what your coefficient of y. You're going to divide everything by that number. So we have the 3 divided by 3, which cancels out. Just give y by itself. We divide it by a positive, so the inequality stays the same direction. Then we have negative 10x divided by 3. Well, negative 10x divided by 3 comes out to just negative 10 over 3x. It does not simplify or reduce. And our final problem, we have negative 15 divided by 3, and that is negative 5. So now we can graph this inequality with a slope of negative 10 over 3 and a y-intercept of negative 5. So our y-intercept is at negative 5, and our slope tells us to go down 10 and right 3. However, we can't go down and right, so we will go up and left. So we'll go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and left 3, 1, 2, 3, and we see our new point. And from there, we will draw a dashed line because this is a greater than inequality and it's not equal to. And since it's not equal to, we will use a dashed line. And since it is greater than, we will pick a point anywhere on the graph and go above it. And we will know that is the answer as far as greater than goes. So the answer for, or the solution for 10x plus 3y is greater than negative 15 is listed there. Dashed line shaded above. The final example we have is 3x minus 4y is less than negative 8. So I'm going to rewrite my problem. 3x minus 4y is less than negative 8. I know that I'm solving for my variable y again, so I'm going to separate my sides, and I'm going to get rid of the positive 3x by subtracting 3x from both sides. Again, our goal is to get y by itself. So the negative 4y will come down. The inequality of less than will come down. And then we have the negative 8 and negative 3x. We'll put negative 3x minus 8. In our final step, we want to solve for y. So our first step was to add or subtract x. The final step is to divide everything by what is touching y, divide everything by the y's coefficient. So we're going to divide everything by negative 4. Now, this brings up a rule that we need to remember. Anytime you multiply or divide on both sides of an inequality, the inequality must flip. So we have y, but since we divided by a negative 4, the less than turns into a greater than. Then we have negative 3 divided by negative 4. Negative 3 divided by negative 4 does not come out to a whole number, but the negatives will cancel out, so that gives us a positive 3 over 4x. And then we have negative 8 divided by negative 4. That does come out to a whole number, so that would be plus 2. Negative 8 divided by negative 4 is positive 2. From there, we know that our slope is positive 3 over 4. We know that our y-intercept is 2. So we will put a circle or our first point at the y-intercept of 2. Our slope is positive 3 over positive 4. So we'll go up 3 and right 4. So from the y-intercept, we'll go up 3, right 4. And there is our second point on our line. And since the inequality flipped because we divided by a negative, we now have a dashed line that we will shade above. The less than became greater than. So we will shade above the line that was given, that was drawn based off of our y-intercept and our slope. So again, our goal is to get y by itself. The first step is to subtract the x, or add or subtract the x from both sides. The second step is to always divide the coefficient by the coefficient that is beside y into everything. And if you multiply or divide by a negative, remember the inequality must flip. Hope this is clear and you understand it. If you have any questions, feel free to ask and I will answer anything for you. Have a good day.